Okay, so yesterday we talked about the triangle side length theorem, how the sum of any two sides of a triangle must be greater than the third side. Okay, well this is the next little part. I think this is kind of the most common sense part of all the triangles, but you really still have to pay attention. I know y'all get tired of me saying that, but you have to pay attention when you get problems with these. And we're not doing a lot of practice with this one, so this page of notes is very, very important. Okay, so what this tells you is the relationship between triangle angles and their side lengths. It tells you that, let me zoom in a little bit more, the smallest angle will lie opposite the smallest side. The middle angle, or mid-size angle, will lie opposite of the middle-sized side length. And then the largest angle will lie opposite of the largest side length. And so if you think about it, if you're thinking about two sides of a triangle, okay, if I make the angle little, the distance between the two sides gets smaller, so you're going to have a smaller side over there. If I make the angle big, the length over here gets bigger. So it makes sense. Small is across from small, middle is across from middle, large is across from large. So for me, the middle is always the hardest one because you don't want to make a mistake. So you usually, when I look at them, I try to do the small one first, the large one first, and then do the middle one last. So let's look at this example. 120 is the biggest angle because it's obtuse. Well, if it's directly across, okay, so you can draw a little dotted line from 97 units. Well, if you look at the three sides, 97 is the biggest. So biggest angle is across from biggest side. Okay, 21 is your smallest angle out of the three. If you look across from it, it's across from 39, which is the smallest of the three sides. And then you're left with the middle. Okay, alright, so if you do the large and the small first, then you're left with the middle. So, like I said, pretty simple. Smallest angle is across from the smallest side. Largest angle is across from the largest side. Alright, so here we go. The smallest side length, okay, is 39. We already said that. 39, 63, and 97. So the smallest is 39 units. And it is opposite the smallest angle, which measures 21. I've got it zoomed in really far. My hand's kind of squished. Okay, so then let's do the largest. The largest side length is here, which is 97 units. And it's going to be across the largest angle, which is 120. And so, like I said, small and large first, and then go do the middle. So the middle side length is what's left, and that's the 63, and it's going to be across from the middle, which is 39. Alright, so make sure you get those down. Alright, and now let's look. If the triangle is an isosceles, so if you remember from earlier, isosceles means it has two equal sides, and so if it has two equal sides, it has two equal angles somewhere. Okay, so it also has two sides that measure the same, so the angles opposite of those sides must measure the same also. So this is kind of sometimes harder for people to think. They call the two sides that are the same legs. Okay, so those legs are both 10. That means the angles opposite of them are the same. So if you think about the little lines we just drew on the other one, okay, and do the angle that's across from it, the one across from 10 and the one across from 10 is the same. Okay? Some people also think that if you have your legs, then the two base angles are the same. So you can think about that too. But since we're talking about the opposite side angles. So here's another one. If these are your legs and they're both 9.5, okay, the two angles that are across are also going to be equal. Okay? So let me look at page number super fast. You are going to put this. Okay, so you're going to take this paper. Now yours is already cut. I hadn't cut mine yet. And you're going to put this on 147. Okay, on 147 on the right side. Okay, if 146 is blank, it's just because we didn't put something there yet, but we will. So 147 on the right here. So tape that in to your journal and go on to the next assignment. Okay, now this is your homework for tonight. If you have time in class, you're going to get to start it. I know the pictures are a little blurry, but you can still see it. But I want to kind of look through it with you real fast. Number 1, okay, just kind of goes over what the theorem says. Now let's look at number 2. I'm not going to do it all with you, but we're going to kind of look at it. They have them labeled like a line AB. That means that's line that's AB. So AC would be this one, BC would be this one. Okay? It tells you the 3 side lengths, and you've got to figure out which side is which. So what I would do is start with either the smallest or the largest, and I'm going to do one of them with you. So 11 is my smallest side. So I'm going to look and see which is my smallest angle. Okay? Well, 35 is my smallest angle, so I know it's across from the smallest side. So that's where the 11 would be. So BC is 11. Okay? So you should do the same thing with the other 2 sides. Alright, now on this one's it's different. It gives you the sides, and then it gives you the 3 angles to match. Alright, so you're going to have to do the same thing. Pick out your smallest angle, and you know it goes across from the smallest side. Okay, so if your smallest angle is 45, my smallest side is 5, so I know that it's across from there. So this one is 45, so angle A is 45 degrees. Okay, so that's kind of how those work. Alright, number 4 is a certain type of thing. Triangle, I almost gave you the answer. Right here shows you these are the same, so that should be your hint of what it is. Alright, and then this one, it gives you the sides, and it doesn't give you the angles, but it wants you to put them in order from least to greatest. So you'll just put A, B, and C in the order they should be there.